This is the air I breathe. This is the air I breathe. Your holy presence.
Hello, my name is Esther Constantine Chan. I'm with
Kelvin Stephen Mtoe.
We are both the students of Form 3 in Kismiri Secondary School.
Now, Esther, what are we going to do today?
Of course, if I'm not mistaken, we are going to conduct an experiment on food test.
And can you mention some of the reagents you are going to use in food test?
Yeah, of course, I can try. We're going to use Benedict solution, sodium hydroxide, hydrochloric acid, sodium 3 solution, together with copper 2 sulfate solution.
Now, Mr. Esther, how are we going to, what food nutrients are we going to test today?
The food nutrients that we are going to test today, we're going to test for the presence of starch, protein, lipids, reducing sugar and non-reducing sugar.
Now, my fellow colleagues, I hope today that you are going to enjoy the exhibition and you are most welcome.
Okay, let's go.
Today we're gonna do the experiment about the food taste, and we're gonna start on the starch. When the food is having starch, the color will change to dark blue, and whenever the food does not have starch, it will retain the color of iodine solution. For example, we have a food sample T containing starch, and also we have food sample H which does not contain starch. Now the procedures. You take your test tube and you take 2 cc of the food sample which contains starch. Then you take the iodine solution. Also, you take 1 cc of the iodine solution. The color will change into dark blue. And also we have the food sample H, which does not contain starch. Now you take the 2 centimeter cubic of the food sample and keep in the test tube. And take also 1 centimeter cube of the iodine solution. And add it to the food sample H. Now the color will retain the iodine solution. Now the food does not have starch.
Today we are going to conduct an experiment on food testing. We are going to test for the presence of reducing sugar in food sample. First, when you are testing for the presence of reducing sugar, you must have a Benedict solution. And if there is a presence of reducing sugar, the color will change from blue to green, yellow, and final red, brick red or orange. The first step is we are going to test for the presence of reducing sugar. You have to take 2 cc of the food sample which contains reducing sugar. This step we are going to take 2 cc of the food sample. Then we add the 2 cc of the Benedict solution, which is the equal amount of the food sample used. Then we are going to heat a bit to see if the color will change from green from blue to green, yellow, and final brick red or orange. But if it won't change, it means that the food sample does not contain reducing sugar. As you can see, the color starts to change from blue to yellow. Then the red color has started to appear. And finally, our solution has become red in color, or brick red in color, we can say orange. We now have the food sample H, which does not contain reducing sugar. As we have seen, the food sample Y contains reducing sugar. Let's test for the presence of reducing sugar in this food sample H. We take 2 cc's of the food sample. Then we add the same amount of Benedict solution in the food sample. Then you have to heat and observe the color change. Okay, as we can see, our food sample started to boil, but no color change. The food sample contained the color of Benedict solution, which shows that the food sample does not contain reducing sugar.
And now we are going to test the non-reducing sugar. Why are we calling it the non-reducing sugar? Because it does not reduce copper 2 sulfate into copper 1. When the food contains non-reducing sugar, its color will change into blue, green, yellow, and later to brick red or orange. And when it does not contain non-reducing sugar, the food will retain the color of Benedict solution. For example, food sample N, which rich in non-reducing sugar. We take the 2 cc of the food sample N and add 1 cc of the hydrochloric acid. Then the solution will be warmed. Are we adding hydrochloric acid in the non-reducing sugar? Because it breaks down the non-reducing sugar into a reducing sugar. We are going to cool it. Now, after cooling the solution, we are going to add the sodium hydroxide. Why are we adding the sodium hydroxide? In order to neutralize the HCl in the solution. The sodium hydroxide required will be 1 centimeter cubic. Hydroxide will shake the solution in order to mix the solution and neutralize the HCl. After that, we add the 4 centimeter cubic of the Benedict solution. Then lastly, it should be warmed. As we see now, the solution turns its color into brick green. Now it's forming a yellow color, and unfortunately it will change into brick red or orange. Now the food substance N contains the non-reducing sugar, as we see the observation from it.
Now we are going to test for the presence of protein in the food sample. Now we have the food sample N, which contains the protein, and also we have food sample H, which does not contain protein. Now the first step is we are going to test for the presence of protein. We are going to take 2 cc of the food sample. Then we are going to take 1 cc of sodium hydroxide. We shake it a bit. Then we are going to add 1 cc of copper sulfate. As we can see, the color has changed into purple. This shows that the food sample contains protein. Now we have another food substance, which is food sample H. Now we are going to test the presence of protein in this food sample. We are taking 2 cc of food sample. Then we add 1 cc of sodium hydroxide. And finally, we add 1 cc also of copper 2 sulfate. As we can see here, no color change. The food sample has maintained the color of copper 2 sulfate. This shows the food sample does not contain protein. Okay, here are the results. This is food sample N and this is food sample H. As we can see, this food sample N is purple in color, while this one has maintained the color of copper 2 sulfate. Therefore, food sample N contains protein, but food sample H does not contain protein.
Now, lastly, we are going to test the presence of lipids in a food sample. To test the lipids in a food sample, we need the reagent of the Sudan 3. And for example, here we have the food sample K. We take at least 3 centimeter cubic of the food sample and we add with few drops of the Sudan 3. And when we are required to shake it vigorously. And the observation made there are the bright red. The color of the bright red ring is formed on the top, and the pale red layer is formed on the bottom. This means that there is presence of lipids in food sample K. Finally, we are going to test the food sample H, whether it has lipids or not. Now we take the 3 centimeter cubic of the food sample and we just add few drops of the Sudan 3. And we are required to shake it vigorously. Here the observation made is that there is no brick red layer formed above, or the pearl red is not formed. This means that the food sample H does not contain lipids.
Alright, we have now reached the end of experimenting. As we can see, the results are there. We have taken various samples of food. But Kelvin, can you tell us what the importance of doing this?
I can tell you the importance of food testing. It enables a person to know the required meal for the balanced diet.
Okay, we have to know what kinds of meal we are eating so as to maintain the balanced diet. But where can we get there is such kind of food stuff that they are being tested?
For example, in lipids. Lipids we can obtain by drinking milk and groundnuts, sunflower and coconuts.
Okay, what about protein?
The protein also you can obtain by eating meat, eggs, and yeah, that's all.
And what about fat?
The fats will be you obtain by